Hello folks, this is video number 17 for the playlist that's devoted to motion design application in 3D experience doing a kinematic problem. The title of the video is, as you can see, recording exact position of an assembly as screenshots. And it really comes from the fact that several months ago, I did a video for the playlist which is devoted to mechanical systems design, which is a different application in 3D experience. And the there was a question by with a viewer that how can I record exact position and name it as I want so that I can go to it later on. Now, this particular tutorial and the question, as I said, was coming from a different playlist. And here's the reference to it. But anyway, later on, I got involved with motion design. Motion design is a glorified version of mechanical systems experience and mechanical system design, where things are done in a bit more cumbersome way. So what I'm going to show, the answer to this question, but done in motion design, not in mechanical systems design playlist, as it was done by this and mentioned by this viewer. Now, I'll make a different mechanism, which is a bit simpler. So uh, basically, I have a fixed base, stationary base. I have a block that's sliding on it. This is a prismatic joint, and I have a propeller that has a cylindrical joint on it, so it can turn and it can go up and down. Okay. Now the parts dimensions don't matter, totally irrelevant. So I'm not gonna make them. Here is the assembly, and what I'm going to do is, first of all, uh, remember when you do these problems, you have two choices. You can create certain engineering connection in assembly design, and they become joints later on. Okay, or you can create these joints directly in the motion design. I'm going to create my engineering connection as an assembly constraint, and then automatically it becomes joints. So first of all, we're going to fix this base. So here is the fix. I'm going to select the base, the big base fix. Then I'm going to create a prismatic joint between the block and the cylinder and the base. So let's go find it. So here is a prismatic under different templates. It really doesn't matter. I'll use this one. Line, plane, plane. So here is a line, here's another line, here is a plane, here's another plane, and I don't need these last set of pieces of information, so I just deleted them. It really doesn't matter, you can leave it, but that's okay, I deleted it. Then I'm going to create my cylindrical one, so we go to cylindrical. I'll use the first one. Again, it really doesn't matter. I have this axis and that axis, okay? And we can leave it the way it is. Okay, I don't need any of this stuff. And if it's bothering you, I can bring this thing down and put it with a snap. It's okay. Snap that plane to this plane, just so that if you feel that they have to be on top of each other, they don't actually. Okay, good, because the cylindrical one not only turns, it goes up and down. But anyway, so let's move on. Now we're going to go to motion design, where I talked about mechanical. Remember, I talked about mechanical system design. Let's see where it is. Mechanical system experience, and mechanical. Uh, what is the other one? Can't remember. Okay, so Yeah, mechanical system design. Those playlists that I did a year ago were using these. This motion design is the glorified version of it. So you click on it, much easier to use. So you say, okay, notice that the joints have been created, prismatic, cylindrical, and fixed. Those have been created. And if you go to the scenario and double click on dynamic step, by default, it's a dynamic step. I don't know what a kinematic step is going to do. And none of these matter because that was not the question that the viewer had. Okay. So here's the situation. If you look at the mechanism tab, there is something called, where is this thing here? Kinematic player. You click on it. Notice that there are 3 degrees of freedom: translation, rotation, and up and down translation. So if this is the initial position, so I can move this thing, for example, there. And if I want to, I can turn the propeller. And if I want to, I can move it up. Now, once you do that, this is the desired location that you want. You click on that fellow, create state scene. You click on it, state set number 1. This is your name. You call it whatever you want. You can call it my state set 1 or my first position, etc. But that's okay. It's all right. Now notice that what happens, the position was created right here, state set 1. Now let's say we move it again, and we move this thing up, and we move this thing that way. And you're happy with that position? So you click on the create set number 2. That's good. Okay, let's do something else. There we are. There we are. And there we are. You can even make it pull through this if that's what you want. So that's crazy, but anyway, yeah, make it like that. Click on this, create set number 3. And when you're happy, I mean, you're done, or if you want to reset it, this is reset all. You click on it, goes back to the initial position. And if you want to capture that, create set number 4. So notice that you can close this, and these are the positions that you are interested in. For example, if I put the cursor on this state set 1, right click and say apply state set, it goes back to that initial position that you were interested in. If you put the cursor here, right click, apply set number 2, there we are. On 3, there. And this was the reset one. If you're interested to capture it there. So hopefully I have answered this person's question, except that I'm not doing it in that particular uh, application. This application was mechanical systems design. I'm doing it in motion design, which is a much better, easier to use, and having functionalities that actually I did not have when I did those 2 other applications. All right, folks. Oh, by the way, I want to show you something here. Uh, if you if you go to the assembly right there, this is the simulation, this is the assembly. You see that this information is also recorded there. So it is it is possible to, even if you don't have the license to motion design, you can display these things using mechanical systems design. Okay, good. That's it. Okay, you can go back here. You're back to where you were, right there. And that's pretty much it. Good luck.